Hi!
I'm Daphne.
And I'm Isaac. Today we're going to be interviewing Professor Merlin Crossley. Let's go. Hello everybody. We are fortunate enough to be joined by Professor Merlin Crossley. Thank you again for taking the time to sit with us this afternoon. We know that you're living on a hectic schedule. We hear that you're flying right after this interview.
Yeah, going to a conference in Oxford on gene therapy. Yeah.
Oh, awesome. What particularly about gene therapy?
On gene therapy for sickle cell anemia.
Oh, which is quite relevant to what we're going to be discussing later on in the interview. So just about your accolades. So you are the Deputy Vice-Chancellor Academic here at UNSW and a Professor of Molecular Biology. You are also an editorial board member for The Conversation, which, by the way, is a fantastic depository of information from academics and researchers. What exactly do these positions entail?
Deputy Vice-Chancellor Academic, anything to do with teaching. So looking after the students, the curriculum, exams, and also enrollments. Professor of Molecular Biology, doing research in molecular biology and teaching molecular biology. I teach a few lectures in third year and just one guest lecture in second year. I don't do that much.
Right. So what about your role as a researcher? Do you spend a lot of the time in the lab?
Yeah, so I've got about 8 PhD students, a couple of postdocs, and they spend a lot of time in the lab. And I go and encourage them. I try to encourage them to a point of exhaustion. And they're working on a whole lot of projects. I spend most Fridays in the lab.
All right, so for our next question, we're going to throw to first year advanced science student Ted.
Hi, I'm Ted. I'm a first year advanced science student and I have no idea what major to choose. What made you do microbiology? And why do research? Hasn't everything in microbiology already been discovered?
That is such a cool question. So at school I liked chemistry. When I got to uni I liked biology. And then I thought, I'll do biochemistry. And I liked biology and sort of went to genetics. And it was pretty obvious. Quite a lot of people just said, DNA is the future. And you can sort of see fields emerging and branching out. So DNA was for me, and I went on like that and have been dedicated ever since. In your second question, I had a friend who I did honours with, and she said, I think everything's been discovered. Well, I thought so too at the time, but it hasn't been. It always looks that way because you can't see over the horizon.
So you've been creating waves in the scientific community for your work with CRISPR gene editing technology, as well as the Cas9 protein complex, creating beneficial mutations that increase the oxygen carrying capacity of the blood. Can you expand on this research and its promise in areas like medicine and molecular biology?
So people have been able to understand DNA from the sort of 1950s, 60s, sequence it in the 70s and 80s, make 1 or 2 mutations in the 90s, but now we can actually edit it properly. And that's fantastic because we now know most of the mutations. And what I'm doing mostly is correcting mutations or editing beneficial mutations which we know will alleviate disease symptoms. So people who have sickle cell anemia have blood which does have a problem carrying oxygen, and it breaks up and clogs people's capillaries. And if you can fix the mutation in blood stem cells, you can cure the disease. Now, at the moment, no one's done that. They've done it in mice, but a human's a lot bigger than a mouse, and it's going to be a question of the efficiency with which you can do this.
So you're able to actually find the area of the DNA that contains the mutation, cut it out using the technology, and then replace it with the beneficial mutation?
So what happens is everything's jiggling around in the cell through sort of Brownian motion. So you don't have to really find anything. If you put in, how DNA is double-stranded, if you put in one strand, it will find the right place where it fits. And what I talk about it in one of the articles in The Conversation, it's like if you had a jigsaw puzzle and one spot was missing, and someone said, put your hands behind your back, close your eyes, put it on the table. If you jiggle around long enough, that piece will find the right place to go to. So we can synthesize small bits of DNA, put them in, they will find the right place to go to, and CRISPR will enable that.
Speaking of CRISPR gene editing technique, our next question comes from Alice. Alice, what's your question?
Hey guys. Hi Professor. We saw that Dr. Jennifer Doudna's discovery showed an efficient way of editing genomic DNA. This was received and implemented by researchers and academics such as yourself through the US and globally. In your professional opinion, how important is collaboration in science?
That's a great question too. So I've never published a paper just by myself. Usually there's 10 authors, sometimes 30. I love collaborating. When you're collaborating with someone, you share the excitement and you also share the disappointment, and both of those things are very important because the disappointments, we don't talk about them, but there's plenty. Having said that, you've got to do your own work, and you can't sort of just think, I'll be one of the people who just helps out, because it doesn't work that way. What happens with a collaboration is one person's an expert on this and the other person's an expert on that, and they seek each other out. So I get asked for particular things because I have learned, we've specialised on editing blood cells, and other people specialise on editing stem cells. And I got an email today by someone who wanted to do editing in stem cells, said, can we learn the techniques from you? And it works. So collaboration's great, but you've got to do your own way or you won't find anyone who wants to collaborate with you.
We know you run a large laboratory here at UNSW and work with a bunch of students, academics and researchers, both domestically and globally.
Yeah.
What's your daily routine like?
Oh, that's a good one. So I get up, I look at all the emails the night before while I have a cup of coffee. Do that. Drive to work. Then answer the emails that have come in while I was driving.
While you were driving.
Then there's usually meetings, and the meetings, some of them are very important for shared wisdom and the wisdom of crowds, that getting things done, prioritising things, working out what to do. I think most people in management of the university would say there's too many meetings, but you need a certain number. Then when I've got a gap in my diary, I'll go over to the lab and I'll wander around and just see what each student's, if they've got any questions, and sit down, and that's a sort of downtime thing. And then I'll come back, and then there'll be a few documents to read for the next meeting, and then maybe some documents to write.
Yeah. So you mentioned going to the lab and wandering around, seeing if people have any questions for you. What if there is a finding and there are various opinions on the finding, and certain number of your students can't agree on their take on a particular conclusion? How do you manage conflict in the lab, and do you have any strategy in doing that?
That's a great question too. So yeah, there's two types of findings really. There's findings which make perfect sense and we say, yes, we're on the right track. And then there's other findings which are, oh no, we've lost our way. And my rule is that if my students get a finding which is good, they email it to me, whether I'm there or not. If they get a finding which doesn't make sense, they only tell me in person. And that's because when they email it to me, I just say, hooray, and that's great. But if it's complicated, I've got to sit down with them and say, okay, we've got to rethink this, and I can help, but we've got to rethink it. Now, in terms of people having dividing opinions, that's really interesting. In my area of molecular biology, it's very rare that you'd have two schools of thought. You may have conflicts about things, but they're not likely to be one person thinks, oh, the experiments worked, and the other one thinks, no, it didn't, or something. It's because there's so much data. We're data rich. The really interesting philosophical areas of science in the past, like evolution and things, that was when there wasn't much data, and then people had different ideas, but there's a lot of data now.
So we have a few very serious questions for Professor Crossley here. The first question, what did the DNA ligase say when it was late to work?
No, I don't know.
I don't understand. I'm lagging behind.
That's very good.
It was internal humor,
That
by
is
the way.
just one of the nerdiest. That's good. Yeah.
Yeah, lagging behind. DNA replication. Do your research. Okay. So thank you so much for your time, Professor. We hope you have a safe flight and enjoy your time at Oxford University. That was Professor Merlin Crossley of molecular biology, the field of science where multiplying and dividing mean the exact same thing. Thank you.